Today we will learn how to represent negative integers in binary. Now the three main ways that you are required to learn. The first is 2's complement, then sign and magnitude, and then BCD, which stands for binary coded decimal. Now 2's complement, you can only represent negative integers. But with sign and magnitude and BCD, you can represent both positive and negative integers. So the first I'm going to use this example, negative 51, and I will show you the steps that you need to take. Now the first step would be to convert 51 into binary. Ignore the negative sign. So I have already converted it, and this is equal to 110011. So this is 51. Now what I need to do, the next step, is to invert the bits or to flip them. In other words, where I see 0, I put 1. Where I see 1, I change it with 0. So this would be 0, 0, 1, 1, 0, 0. I had a 1 here, so I switch it and I put 0. I had a 1 here, switch it and put 0. I had 2 zeros here, so I switch them and put 2 1s. And repeat the same thing here. So we are finished with this. We no longer need this. This is what we are working with now. The last step is to add 1 in binary. So I simply put plus 1. 0 plus 1 well as 1. Then I bring down the other values. Base 2. And that's our answer. That's equal to negative 51. Now with sign and magnitude, it's a lot different. So again, we have to convert 51 into binary. That's always the first step. So 51 again is 110011. Now we are going to do the 8-bit sign and magnitude representation. Now remember, bit stands for binary digit. So we need to represent negative 51 in sign and magnitude using 8 bits. Now what I would advise you to do is to make the number that you converted 7 bits and then indicate the sign. Right? So currently we have 1, 2, 3, 4, 5, 6 bits here. We have 6 bits currently, and in order to make it 7, we will need to add 0 to the left. It's always to the left. If I add it to the right, then I am changing the size of the number, and I don't want that. So I add 1 0 to make it 7 bits. Now if the binary value you have already has 7, then there's no need to add any 0. If the number I have has, let's say, 5 bits, each of these they are called a bit. If the binary value I have has about 5 bits, then it means I need to add 2 zeros instead of 1. So it depends on how much bits you have. You just need to add the required amount of zeros until you get to 7. Alright? So the next thing you have to do is to indicate the sign. Now in sign and magnitude we put 1 for negative and 0 for positive. Now because we are supposed to find negative 51, then I need to put a 1 at the front. And this is our answer. So this is our sign, and the remaining numbers as the magnitude or the size. So in all, we end up with 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. That's how you find 8-bit sign and magnitude. So you add the required amount of zeros until you get 7 if necessary, because it may not always be necessary. Then you indicate the sign. If this was positive 51, then the answer would be 0, 0, 1, 1, 0, 0, 1, 1. This is the sign. The first bit to the left is always the sign. It depends on whether the number is positive or negative. So please keep that in mind. And of course, you have to put your base. Now remember, when you're adding your zeros, you must add it to the left and not the right. If I had the number 25 and I put 0 in front of it, it is still 25. If I put another 0, it's still 25. Never mind that it looks different or it may look strange, but the value is still 25. So it's the same concept we're applying here when we're adding zeros in front. Now for BCD, most students find BCD to be a lot easier than the others. So again, negative 51. Now we are not going to convert 51 into binary, not the entire 51. With BCD, we're going to convert each digit into its 4-bit representation. What do I mean by that? Well, the number 51 comprises of a 5 and a 1. So we have to convert 5 into binary, and then we have to convert 1 into binary. Right? But there's a catch. You have to indicate it in 4 bits. So I convert 5 divided by 2 0 0 remainder 1. So 5 is 1 0 1. Now 1 in binary is 1. Now remember I said we need to make it 4 bits. We need to represent every digit in 4 bits in binary. So currently we have 1, 2, 3 bits for 5. Right? But we need 4. So what do? Just like we did over here, we add a 0 to the left to make it 4. With 1, we need to add 3 zeros to make it 4. And for the sign, for negative numbers in BCD, to the front we put 1 0 1 1 for negative, and 1 0 1 0 for positive. Okay? Now because this is negative, then obviously I would put 1 0 1 1, and this would be this entire thing would be the answer. 1 0 1 1 0 1 0 1 0 0 0 1 base 2. This should be our answer. So I convert 5, I convert 1, and this would represent the sign. This is negative. If it was positive, then it would be 1 0 1 0 0 1 0 1 0 0 0 1 base 2. Now if I give you a number like 58, right? 8 in binary is 1 0 0 0. Now 8 in binary is already 4 bits, so again we don't need to add any additional zeros because it is already represented as 4 bits. If I give you 0, then you need to add 3 more zeros to it to make it 4 bits. You always have to keep it 4 bits.